in Matthew, the given information, the initial amount that he gives is 1 penny, and so they're trying to compare it, and he's doubling it every day for a month, the amount of the output. And so they're comparing that to $100,000 to see which the better choice is. So on the initial amount was 0. At day 0, it would be 1 penny. On day 1, it would be 2. Day 2, 4, and so on. And so the students have to complete the rest of the information. On day 4, it would be 16. And on day 5, it would be 32. And on day 6, it would be 64. And then on the first week, so he said it would be $1.28. So the 7th day was 128 pennies. And so then I asked the students, well, is this going to be a linear function? When we graph the given information, the y-intercept is at the initial amount's at 0, 1. And then on day 1, it was at 2. And on day 3, it was at, on day 1 it was at 2, and on day 2 it was at 4. And then on day 3 it is at 8. So I asked, is this linear? Well, it doesn't look linear on the graph, it's curving. And so it does not look linear. If we look at the pattern and they subtract the output values, 2 minus 1 would be 1, 4 minus 2 would be 2, 8 minus 4 would be 6, and no, it is not increasing at a constant rate, therefore it is not linear. So then I asked, well, what is happening to the output? If we look at the output, it's 1, 2, 4, 8, it's being doubled. That's a student's observation. And that's what the math dude said, he would double the output and from the previous day, and so it's being multiplied times 2. Well, students automatically want to write that the equation for this is 2x. So then I have them check with the table, is it going to be the function y equals 2x? Well, 2x, what type of equation is that? Well, if we try the input value, if we put in 2 times 0, you output 0, and on day 0 we should have got 1. If you input 1, you get 2. That one comes out correct. If you input 2, you get 4. But then when you get to day 3, 2 times 3 would be 6, and it would not be 8. So for one thing, this equation does not match the table. For another thing, what kind of function is 2 times x? Well, it's a linear function because it's x to the first power. And so I said, well, what is happening with the output values? How else could you write the equation to match the data? And I keep questioning students. It did take a little bit of effort and guiding them to get to that these were 2 to the power. And so how do you write that as an equation? And that would be 2 to the x. So you know that 2 is the base, and then and some students had tried to get that and could not successfully get to the 2 to the x for the equation when they were working through it themselves without being questioned. And so then if you plug in, let's check that. So if we put 0 in for x, 2 to the 0 power is, anything 0 power is 1. If you put in 2 to the first, you get 2. 2 to the second for x, you get 4. 2 to the third, you get 8. And so this is the exponential function. So this is an exponential growth function because y is increasing rapidly as x is increasing by 1s. And so this is the first introduction to exponential growth.